We shall start the session again. Okay, so here we are taking first 10 images. Okay, then we are storing it in this particular variable data. So 2 rows, 5 columns. Subplots we are creating 2 rows and 5 columns. Like yesterday we did, right? Do you remember? Yesterday we created subplot 2 rows and 5 columns. Adhe tarah we are doing it now. Okay, and this is the height and width x and y axis. Okay, so you're storing it in this particular variable fix and ax. So this particular method will flatten the 2D array into 1D array. Okay, so this ravel method will flatten the 2-dimensional array into 1-dimensional list. So you're just going to display the image, you're going to iterate through the image and the label, okay, and then you're going to display it, that's all. So 10 images, so 2 rows and 5 columns, we're going to pick 10 images here. 5 and 5, 10. So here you're printing the image and this is for printing the title, the label name. Okay. Yeah. So it's a very much. Completely is Excel item. Excel. This will convert to the array into 1D list. And example, just to enumerate the data. Data will have 10 images. So one image we have. So this example will already have the image and the label is already stored in the example. Okay, so you're going to iterate the 10 images. Image and label is already there in this example. We have already given this. So here we have already converted that particular tensor to numpy and we are storing it in this particular variable image. It needs to take the ones. Okay. After this, what we have to do is, yesterday we did no. So take every image. Okay, you have to apply CNN to all the images. Okay, yesterday we did this right for the data set, whatever we have used, right? Fashion MNSAT data set, whatever we have taken that. So you remember yesterday we took those that fashion MNSAT data set from OpenML, right? So we took individual image and then we applied convolution CNN to that particular image, and then we also applied the softmax, okay, and all those things to every image, right? So that is what we are going to do. We are going to pick individual image and we are going to apply this CNN to those images. Getting it? So we have how many classes of image we have? We have five, right? So tulip, dandelion, roses, daisy, and sunflower. Okay, so we are going to take this individual image and apply CNN for all those images. This is what we are going to do. Okay, so we just plotted it, and now we are going to pick individual image and then we are going to see. Come under your feature maps and feature extraction. So you're going to pick individual features from this particular flash. After that, you have this classification. So the final classification will be softmax. We'll be using softmax because the flower is going to be either out of these five classes. So it is categorical. Once it is categorical, you have to use softmax. Okay, for the final thing. Okay. See here, one small change. We are using this image generator, image data generator. Okay. So this will generate the image for us. Okay, in that particular folder. Okay. So 32 batch we are going to have. Point 2 is 20% for testing we are going to have, and the pixel value is from 0 to 255, that particular image. So you are dividing that by 255. Okay. And so you have one for training as well as one for testing we are going to have. Okay. So the class mode is categorical. Okay. The categorical thing which we are going to. So you're converting this image to 224, comma 224. So every image is getting converted here, 224, comma 224. And the batch size is 32 here. And the class mode is categorical, okay? Because, either of these five which we are going to have, and we also have this, one is for the training purpose, other one for the validation, okay? Um, Okay, so from your directory, it is going to train. So there will be a separate directory for train generator as well as validation generator. Okay, so separate directory you have. From that particular directory, you are going to create different batches, and then you are going to train. This is for training, and this is for testing. So for testing, we have point 0.2. Okay, 80% for the training, and all the images are of the pixel 0 to 255. So you are dividing that by 255. Okay. and this will automatically, this image data generator will generate the image for us. So we have to import that particular library from Keras, this particular library. Okay, so is it fixed? Yeah. Yeah.
Data not given.
You have given?
Data is not given.
Okay, please give us.
Yeah.
Poca,
Done.
four or five hours last. That's it.
It's okay.
Flat.
Flat up.
That is volume is of the convolution line. ಇದು
Important amount that.
ನೀವು ಯಾವಾಗಲೂ ಎಕ್ಸಾಮ್ ಕಂಡಕ್ಟ್ ಮಾಡಬೇಕು ಕ್ಲಾಸ್ ಕ್ಯಾನ್ಸಲ್ ಮಾಡಿ ಅಂತಿದ್ರು. ಆಕ್ಸಿಸ್ ಏನು ಕಾಪಿ ಮಾಡೋದು
ಆ ವ್ಯಾಲ್ಯೂಸ್ ಇದು ಮಾಡಕ್ಕೆ ಹೈಟ್ now run all this.
ಇದು ಚಿಕ್ಕ ಮಾಡೋದು ಜಾಸ್ತಿ ರೋ ಮತ್ತೆ ಕಾಲಮ್ ಜಾಸ್ತಿ ಒಂದು
Okay, so this first method is for image generation. Okay, so this method we are using a part of your keras for image generation. And this we have already used yesterday, right? Convolution 2D maximum 2D cooling dense as well as flatter. These two we have already used yesterday. And only thing is like we are adding this particular, we are importing this particular library. Okay, so after that, this particular image, we're going to divide that. The value will come anywhere between 0 to 1. Okay, so this 255 is for the pixel which we are using it. Okay?